All right, hey people, so today we're going to talk about quadratic functions. They're a little bit different than linear functions, so let's dive right in. What is a quadratic function? This is a function in which x is squared. So the most basic quadratic function is y equals x squared. All right, here's what a table of this function would look like. If x is 1, you would square it and you'd get a y of 1. If x is 2, you would square it and get a y of 4. If x is 3, you'd get a y of 9. If x is 4, you'd get a y of 16. All right. We're going to practice. We're going to complete each of these function tables. Okay. So in this first table, our function is y equals x squared minus 1. So we're going to start by plugging in all of our x's and then finding our y's. So if x is 1, our function would look like y equals 1 squared minus 1. All right, 1 squared is 1. 1 minus 1 is 0. If x is 2, our function would look like y equals 2 squared minus 1. 2 squared is 4. 4 minus 1 is 3. If x was 3, our function would look like y equals 3 squared minus 1. 3 squared is 9. 9 minus 1 is 8. And if our x is 4, our function would look like y equals 4 squared minus 1. 4 squared is 16. 16 minus 1 is 15. Pretty straightforward, right? All right, over here is another table that we're just going to practice. The function is y equals 2x squared. So if x is 1, our function will look like y equals 2 times 1 squared. All right, 1 squared is 1. 1 times 2 is 2. If x is 2, our function will look like y equals 2 times 2 squared. 2 squared is 4. And then 4 times 2 is 8. If x is 3, our function will be y equals 2 times 3 squared. 3 squared is 9. 9 times 2 is 18. All right, and if x is 4, our function would be y equals 2 times 4 squared. 4 squared is 16, and 16 times 2 is 32. You see how much they're increasing by much more each time, okay, as compared to linear equations. All right, how do we write a quadratic rule? So if you have an input or an output table like this one we see here, so x is 1, 2, 3, or 4, and then y is 3, 6, 11, 18. We want to write a quadratic function rule for this. Here's what we would do. First of all, you know that x has to be squared here. If we know that this is a quadratic function, we know that x must be squared. So figure out what x is, and we can just put that in our table. All right? So I could make another column for x squared. All right, so 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. All right, since once we have that information, we can decide what must be happening to get from x squared to y. All right, so we know that, okay, we've done this before. We look and see, are we adding something? Are we multiplying something? Or are we doing a combination of the two? So first, just try and see, is there a constant that we're adding to x squared to get y? So 1 plus 2 would give you 3. 4 plus 2 would give you 6. 9 plus 2 would give you 11. And 16 plus 2 would give you 18. So we must be adding 2 to x squared every time. So that is pretty simple. So that must mean that y equals x squared plus 2. And that's our function rule. All right? Okay, let's move forward. right, so we're going to write a quadratic function rule for each of these tables. Okay, so for this table, we're going to figure out what x squared must be. So just like before, 1, 4, 9, and 16. Okay, so are we adding anything constant here to get from x squared to y? 1 plus 2 is 3, all right? So is 4 plus 2 12? No, it is not. So we're not adding a constant to x squared to get y. Maybe we're multiplying a constant from x squared to get y. So what times 1 gives you 3? 3. So 4 times 3, is that 12? Yes, it is. 9 times 3 is 27. And 16 times 3 is 48. So we have a constant. We are multiplying by 3. So that must mean that our function rule is y equals 3x squared. All right, let's try this table. All right, so we're using the same x's. We're going to have the same x squareds. All right, so let's see, is there a constant that we are adding? So adding negative 5 to 1, so 1 plus negative 5 would give us negative 4. 4 plus negative 5 would give us negative 1. 9 plus negative 5 would give us 4. And 16 plus negative 5 would give us 11. So our constant must be we're adding a negative 5 to x squared. Or subtracting 5. Same thing. Let's go with subtracting 5. All right, I hope that makes some sense. We're going to plug along here. Okay, now graphing quadratic functions is really what makes them different than linear functions or linear equations. Remember that linear meant that they go in a straight line, they form a straight line. Quadratic, quad makes you think of 4, right? Well, a graph has 4 quadrants, and a quadratic function, when you graph it, can potentially be graphed in all 4 quadrants. In order to do that, it would have to make a curve. All right, and we call that curve a parabola. Okay, so here's what I have. We're going to graph it like we would any other function. We would get our x's and y's from our table, and just for the sake of argument, we're going to include a few negative x's. All right, and it is going to form a curve. So here I've got a table that I'm going to complete first, and then I'm going to get my x's and y's. All right, so if my function is y equals x squared plus 1, I plug in my x's. Okay, now you need to know a little something about exponents to do this right. You need to realize and you need to know that whenever you square a number, no matter if it's positive or negative, you are going to get a positive answer. So our first function here, y equals negative 2 squared plus 1, negative 2 squared is positive 4. Because remember what an exponent means. This means negative 2 times negative 2. So a negative times a negative is always a positive. So negative 2 squared is 4, and 4 plus 1 is 5. All right, here we have y equals negative 1 squared plus 1. So negative 1 squared is a positive 1, so 1 plus 1 is 2. 0, if we use 0, we have y equals 0 squared plus 1. 0 squared is 0, and 0 plus 1 is 1. 2, if we have a positive 2, y equals positive 2 squared plus 1. So 2 squared is 4, plus 1 is 5. Now notice how we got the same y from 2 different x's, how they're opposites. So opposite integers in a quadratic function, opposite x's in a quadratic function will give you identical y's, okay, because of the nature of a squared number. All right, so these are our pairs. So I'm going to plot this pair, -2 and 5. So -2 and +5 would be right there. Okay, and -1, 2 would be right here. 0, 1 is right here. And then +2, 5 is right here. So when I connect my dots, you can see I get a curve, and my line isn't very good. But that's what your parabola will look like. Now, this only crosses 2 quadrants, but you can see, I mean, it could, depending on the function, it could curve through all 4 quadrants. And that's it. So thanks for joining me.